Hi, thanks for watching my lesson today. Today's lesson is a sixth grade science lesson on the theory of plate tectonics. The target skill for this lesson is to understand the theory of plate tectonics and apply this to explaining the causes of earthquakes and volcanoes. My lesson will be in three parts today. The first part will consist of a hook where students make observations based off of pictures and a very short video of earthquake impacts and volcanic impacts on the Earth's crust. That will lead us into the second part of my lesson, where students are going to focus on important vocabulary and diagrams representing the three types of plate boundaries and the three different stresses and reasons why we have rock stress under the Earth. Students will take notes on a note-taking template that I have provided for them, and they're going to use the program called Cami to annotate for their notes. They will then upload their notes for classwork accountability, and the way that they will upload their notes is by downloading a PDF and then uploading it to the Canvas submission page. Finally, the third part of the lesson will be a choice board for the formative assessment, meaning that I call it the brag board, where students get to choose which task they would like to complete to show that they have understood the material and mastered it to their specific level of understanding. So let's start our lesson. Okay. All right, students. You are going to see a series of pictures, and today we're going to focus on earthquakes and volcanoes. The first series of pictures today show devastation from earthquakes, and all I'd like you to do is put some observations that you are noticing about anything in the picture in the chat. All right, so I see some coming through already. I see cracks in the road, rock levels higher and some rock levels lower. I see a fancy word called a fault line. Excellent. I see some people saying the road is destroyed. Fabulous observations. Okay. Here's another picture of an earthquake. And now I see some observations that are targeting this massive split in the crust, right? This is your continental crust. Prior to this lesson, we've already talked about the layers of the Earth. So you're definitely using your knowledge of the crustal plates and the continental crust. I like that. Some of you even mentioned that it looks like the plates are, going in opposite directions, but at the same level. So that's a great observation. A big crack in the crust, a massive fault line. And I can see that some of you said that the bridge or cars are destroyed or buildings are destroyed on top of the continental crust. Absolutely great. Great observations. Okay. The next three pictures are going to be pictures from an earthquake in Alaska. So the first one shows some similarities to devastation from the first earthquake picture. And that first earthquake picture was actually taken in California. But this one that you're looking at is Alaska. So I can see that some people are also saying that it looks like one side went up and one side went down from the fault line. Yep, very good. And I can see that a lot of you are mentioning, again, that crack in the crust. Excellent. Okay, here is another picture that I want you to pause for a minute and cite some observations. Fabulous. So I see that some of you are now noticing that there's a number down here of 7.0, right? And that number tells all of us the severity or the devastation impact of this earthquake. So well done. I'm glad that you spied this. And you can see that this is coming from Anchorage, Alaska, right? So clearly, an earthquake that has a 7.0 ranking on this scale causes some severe damage because you can see that fault line, that big crack in the crust. So nice observation. I'm glad you targeted that, everybody. Here's our last picture from an earthquake zone in Alaska. So if you're wondering where Anchorage, Alaska is, it's right here. And now what I want you to hone in on is location. So there is a lot said for the location of continental crust and oceanic crust. And some of you are saying that you see some rings here. And those rings are going to be really important as we get further into studying earthquakes and the different stresses that the rocks have underneath. But for right now, I'm noticing some other observations coming through that could give us a good jump start on the causes of earthquakes. And remember, that's our focus for today. I see some of you mentioning the ocean water hitting the land, and that's a really great observation. I want you to keep that in your head because that has a lot to do with stresses on rocks and plate boundaries. And you can see that there's a little outline right here in the ocean, and that's going to be really important for us to remember as well. And these rings are called seismic waves. And this seismic wave is the point where the rock is cracking underneath the oceanic crust. So you can see this is the blue water and this is the rock area. And all of those vibrations of shifting rock come from this one breaking point where the plates have shifted and caused the rock to break. So all of those rings reach all the way into Alaska and cause some fault lines on our continental crust. Okay. Our last pictures are from Haiti, which we all know has some serious, devastating earthquakes as well. And some of you are coming into the chat saying, yes, it's a 7.0. Very good observation. So earthquakes are not only ranked by severity, but they're also ranked by location too. So identified by location. And this is the point where the rock is breaking, and you can see all of the vibrations and seismic activity coming out from that, much like when you throw a pebble into water, right? There's that ring of vibration of disturbance that grows from it, but eventually it goes away. That's the same thing as the rock damage and cracking and vibrations underground. Eventually, the further away those vibrations are, the less damage, right? But if you're really close to that breaking point of rock underneath the ground due to rock stress, then you're going to have some serious damage. And a lot of you are also noticing ocean hitting land. That has a lot to do with it too. And this is my final picture of devastation in Haiti. And hopefully you are observing that it's not just the continental crust or the oceanic crust that gets broken with a fault line. Any building that's man-made that's not with strong structural support or is built on soil that might be more sandy and not as dense, like clay, for example, those buildings can vibrate back and forth and sway back and forth with the vibrations of the ground, and they can topple over and be destroyed as well. Great observations about earthquakes. The last minute of our observations today is going to be a video. And this video I'm going to play in a smaller screen here, actually a larger screen here. And all I want you to do is make some observations. And again, you can put them right into the chat feature if you choose to. And we're going to use your valuable insight today to help with our notes. Okay? I have it on silent mode purposely so you can focus more on the picture. Okay, so some of you are automatically coming in with some great observations of magma rising and looping down below. And it looks like it's pulling some of that crust along with it, right? So there's some rings of magma underneath the oceanic crust. And some of you are noticing a crack right at the top of the crust where magma is coming up. Excellent. Some of you are noticing that one plate seems to be going under another plate. That's going to lead us to a vocabulary word today called subduction. I really like how you're noticing magma pooling and gaining more momentum and it's less dense and it rises. And yes, it becomes a volcanic eruption, but primarily because the rocks have shifted, causing a weak spot in the crust. So well done, everybody. We've got some great observations to work off of. And with that being said, we're going to go to the link that I sent you. And the link that I sent you is a Cami link, and it's going to allow you to take your fantastic notes today based off of the video or the pictures and our observations. So we're going to add to that. So we're going to take your good information and make it great. Okay? So you can see that the title of your notes is 3 types of plate boundaries. So our takeaway today is to understand the 3 types of plate boundaries and why plates move the way that they do due to certain stresses. Okay? So I'm going to focus on this first picture here. Okay? And this first picture here is labeled divergent plate boundary. In that picture of the volcanic eruption and that first picture that some of you noticed, a couple of you said that, hey, it looks like the land and the crustal plates are pulling apart. And this is one way that Earth's crust or oceanic crust can move. They can pull apart, and they can pull apart at a weaker spot in the crust, typically where 2 plates meet. And sometimes there are 2 sections of our Earth, and we've already talked about the layers of the Earth, right, and the plates. Sometimes there are 2 oceanic plates and they meet. But where they meet is that weaker spot, which is right here. Okay, so I'm going to invite you to go to your drawing tool, and I'm going to choose red because I want to focus on the magma first. And down below here, well below our oceanic crust, so these are 2 oceanic crust plates underneath our water, we've got some magma brewing, right? And this magma, as you saw in the video, moves in circles. These are going to have a big part of our conversation today because this magma is constantly moving in currents underneath the ground. And these currents have a certain vocabulary word. So let's add in our first vocabulary word, and that is going to be called convection currents. Now, you can either write this with the drawing tool or you can type it with the text box. That's totally your choice, whichever one you like to do. I'm liking to color coordinate with the same type of drawing, so that's how I'm using mine. But you can certainly go to the text box and you can type in the word convection currents. Okay, and these convection currents are really the loops of magma, right? There's less dense magma rising, that's a super hot magma, and then it cools a little bit, not that much, right? It's still melted rock, and then it sinks. And then under the heat and pressure of the earth in the inner core, it rises again. So it's in this constant motion, right? And I'm going to write magma here as a starting point, right? And we have less dense, LD, and more dense. And these are constant loops. Well, these loops are like a conveyor belt, kind of like it carries whatever is on top of it in that direction, right? Much like a grocery store, right? You put your stuff on the conveyor belt and it just carries the groceries along to the register. Well, that's what these convection currents do with magma. So I'm going to go to basic black for a moment because I really want this to pop. So I'm going to ask you to go to the color black on yours, and you're going to exaggerate these arrows, even though there are some little arrows here. This is what's going to cause your plates to pull apart. And when plates start to pull apart, you end up getting a crack, right, in the crust, that whole line of where they meet. And this crack is like your fault line, but underneath the water, it's primarily called the fissure. So here's another vocabulary word that I want you to jot down, the fissure. Not like a different spelling than a fish, right? Two S's. And this fissure is your crack in the crust. And in this case, it's oceanic crust, crack in the crust. And again, you can use a text box to type this too. And with this crack in the crust, specifically oceanic crust, that's going to allow for a weak spot. So this gives us a weak spot. And the weak spot is fantastic for magma because that allows the magma to rise. So magma is going to start to ooze out, right, and pile up and cool and create new rock for the oceanic crust. The last thing that we need to add to this, besides this vocabulary word of a fissure and these two vocabulary words of convection currents, and this is a diverging plate boundary, is a type of stress that these rocks are causing. And the type of stress that these rocks are causing is tension stress. So go ahead and circle these and bring some attention to some of your literacy, right? Because vocabulary words are so important in all subjects, but since we're focusing on science, it's important to have some science vocabulary words. Plus, you'll sound really cool at dinner table conversation, right? You can talk about tension stress and fissures and convection currents. It's quite interesting. So the tension stress is caused by the convection currents pulling apart the rocks in different directions. Like many of you noticed in that first picture, you said the land looked like it moved in opposite directions, right? Pulling apart. One went to the right, one to the left. Okay, let's pause for a minute. Everybody good on this first picture? Excellent, excellent. Let's go to the second picture. Okay, your second picture, we've got a transform plate boundary. So let's circle that. Well, transform plate boundaries are a little bit different in how they move. They're still going to cause an earthquake, so it's still really important to know that that can happen. It can still cause some magma to be able to seep up in a weak spot, but the plates that are joining move in a different direction this time. It's almost like they slide. They're sliding in opposite directions. So one's not up and one's not down. They're still at the same level, but they're just sliding, right? One's not up, one's not down. So that's why you see these arrows here. And you don't see yet rock elevated higher and rock elevated lower. Not yet. Nor do you see that really here. Okay? So the stress that causes this, I did type this part in for you, is shearing stress. So let's go ahead. You can either highlight that if you want to highlight it, or you can circle it, right? There are all sorts of tools here from which you can choose if you want to highlight. Okay, and this shearing stress makes the rock move in opposite directions. A location where you're going to find this primarily in our area of the world is in California. So I'm going to write in California. Now, California borders the water, right? So if California is here, here's our California, and here's the water, right? We're going to get one plate to move in one direction, another plate, the oceanic crust plate that's hitting it, to move in the other direction, and it slides. And that's why we have so many rock disturbances, because eventually the rocks just crack, right? When the pressure builds up, and that causes all those vibrations into California and can cause some serious fault lines and some damage. Right. So we have one of the longest fault lines in the world in California because of shearing rock stress being on a transform plate boundary. Okay, so the Pacific plate is moving in this direction and California is moving in this direction. So the North American plate is moving in the opposite direction. Okay, any questions on the second type of plate boundary? All right, let's go to the third. This is our final type of plate boundary. And this one, I'm going to now ask you to label the stress with me. So the first two, I labeled them for you. Let's label it together for this one. So you're going to notice some differences. And a lot of you mentioned this before in especially some of the pictures and the video that we started off with. Some of you said, hey, the plates seem to be squishing together, right? And in the video, some of you came through correctly stating that one plate looks like it's sinking below the other. So this type of plate boundary you're going to see is a little elevated, right? And in some of your pictures, some of you said, hey, the land is high and the land is lower on the fault line, right? On opposite sides of the fault line. This is very true for this type of plate boundary, which is called the convergent plate boundary. Okay, this is our third type. And the converging type of plate boundary has, again, all of those convection currents underneath causing the crust to move, right? Just like in all of the other plate boundaries, even here, right? There are convection currents causing these plates to move. And here's another set of convection currents, meaning less dense magma rises and more dense magma sinks. And it's causing these to move in certain directions, right? This direction here is colliding with the plate moving in this direction. So they are converging, right? This type of stress, this time let's go to the text box. This type of stress is called compression. Compression stress. Stress. And with compression stress, I'm just going to move that over here. It's exactly what it really is, right? It's rocks being pushed together. So rocks pushed together. The first one, rocks were pulled apart, right? This is compression showing rocks being pushed together. And eventually something has to give, right? Two things can't take up the same space at the same time. So one layer of rock that's less dense will go up, and one layer of rock that's more dense will sink. And that's what you're seeing here, this compression stress. There's a vocabulary word that's very important that we note here. So I'm going to write in that vocabulary word with my drawing. And you can keep on the text box too. And that vocabulary word goes right in here. I'm going to change that color so it's a little more noticeable. It goes with the fault line crack right here. And this is called a subduction zone. Sub meaning below, right? One plate goes below. Subduction. Don't want to go over that. I guess my picture is kind of blocking that. So subduction zone, we'll write it up here. Subduction zone. So this really means that one plate goes below another plate. And when one plate goes below another plate, we've got a lot of stress in rock, right? Eventually the rock breaks and you start to get the damage in the form of vibrations from the rocks shifting. That's when we see those seismic waves, right? So that's where the rock breaks and we start to see all the vibrations, and that can cause the earth to shake. We also get weaker spots in the crust, and we can get magma and volcanoes to happen on subduction zone areas. Okay. And this picture here is the same thing, but with ocean and land, only because I really wanted you to be able to see where what really happens with Alaska. Okay. So imagine this Alaska, this is the land, and here is your ocean, right? That hits Alaska. So you're looking at the Pacific Ocean plate. Well, the Pacific Ocean gets pushed towards Alaska and it subducts. right? There's your subduction zone right here. And in that subduction zone, you're going to have compression stress. So here's compression, right? That's when the rocks are getting squeezed and forced together. And once they get squeezed and forced together, something has to give, right? It cracks. And when the rocks crack, it sends all of those vibrations out, right? And that can cause tsunamis, right? Because it can cause shifts in the water to come on land. It can also cause volcanic eruptions like you see over here. And it can cause some massive earthquake fault lines here right on the land. Okay, so this is the example of Alaska. It is a converging plate boundary, right? Not diverging and not transform, converging. The transform plate boundaries is what will happen in California. So if this is a converging plate boundary, could be like in Haiti, it could be in Alaska where land meets water. And this is the type of plate boundary in California. Hopefully you're wondering, well, where's a type of plate boundary that could be diverging underwater? So we're going to close out this part of our notes with the final picture that we're going to label. And here's our final picture. It's of most of the world here, right? So we've got a lot of the plates labeled. We've seen this picture before, but since that picture, I've added to it, right? So now we're going to notice a couple of things on this picture. The first thing I want you to notice on this picture is way over here. This little seam, kind of big actually, goes all the way down the ocean. This is called the Mid-Atlantic Ridge, and it's actually underwater. And it's an underwater volcano chain, right? So what happens is this plate is being pulled in this direction from the ocean. This plate from the ocean is being pulled in this direction. And these are your diverging plates, right? So you can even label that if you choose to. These are your diverging plates. And that is caused by the tension, right, in the rock stress pulling apart. And these diverging plates cause a weak spot where magma can ooze up, causing underwater volcanoes. And every time an underwater volcano erupts, you get magma that cools into new rock. So you start building up rocks. And that's how islands can form. At the tip of this mid-Atlantic ridge, this underwater chain of volcanoes on a diverging plate boundary, is Iceland. And Iceland is a volcano, right? It's just a volcano that's been built up with rock and rock and rock because plates are diverging. And the last thing on this picture that's noteworthy is this ring of fire that you see. Well, fire means the magma that's erupting from the volcanoes. So you're probably spying, like I am, that this is the Pacific plate, right? And this Pacific plate hits this land and this land. So this is a situation where water hits land. These are your converging boundaries. Converging. Because land is being forced and water is being forced in a direction where it's going to meet and hit each other through compression force, right? Because of those convection currents of magma way down under the ground. Well, we all know when water and land hit, we get a subduction zone, right? And that means that the oceanic crust is more dense and it's going to sink below that continental crust. And sure enough, it's going to cause a fault line. And you're going to get volcanoes to erupt, like those little red dots, and you're going to get earthquakes. And it's this whole ring, which is why it's called the Ring of Fire, where we have most of our volcanic eruptions and earthquake zones because of converging boundaries with compression stress. Okay? Compression stress, which we've already labeled above. So we're going to pause for a moment And we're going to have you download this. So you're going to go to Downloads right up here, and you're going to place all of your hard work in your Google Drive folder. Now, if you need my notes, because some of you like to have my notes as a reference and you're better off paying attention in class by watching and then seeing my notes later, or some of you just like them as a backup, I'm also going to put my notes on the Canvas page so you have access to everything that we talked about in class today. And I'll place our recording on there too. So that should hopefully make sure everybody has the same information, right? To end today, we're going to allow you to choose a task. And the task is a 2 or 3 day task. So don't think that this is just in one day. And the task is off of your plate tectonics brag board. So the next couple of days, we're still going to be working on this and break it down a little bit more. But some of you like to get a jump start on it. So let me explain the jump start, and then we can let you start on this. So the PictoChart poster option is asking you to use this site, and you're going to develop an infographic, like an informative picture showing the 3 stresses that cause each of the 3 plate boundaries. You're going to explain how a volcano or a fault line can form. Some of you might like that option. Choice 2 is for vocabulary, right? So if you have a goal that you're trying to work on your vocabulary, this would be a great choice for you. You get to make your Quizlet, and you have flashcards with pictures that you can put on them, and you're going to include the stresses, the plate boundaries, and a thorough description of how those stresses cause each of those separate plate boundaries. If you want to create a stop animation, you can also do that with the Stop Animation app. If you have some really cool manipulatives around your house or Legos, you can set up how plates move, right? And the different stresses. So you could show a subduction zone. Twizzlers work great for that, right? Because they go down below. You could show a transform boundary in California. You could show a diverging plate boundary in the mid-ocean ridge. So you could get really creative with your stop animation video. I'd love to see them. We can post all of these on the Canvas page and have a celebration when we're done for everybody to understand. There's 3 other options that you could choose from. There's also a literacy option. Say if you're in the mode for writing, you could write an online article where you could report about an earthquake or a volcanic eruption. You'd have to state the location. So much like when we observed land and water meeting, you want a specific location so you can convey the certain type of plate boundary for your article and the stresses that cause that earthquake or volcanic eruption. You could create a comic strip if you're feeling more like in the mood of drawing, maybe some funny captions that go with it. So you could explain the 3 types of plate boundary motions causing earthquakes and volcanoes. Again, you want to put the stresses in it because that's part of our vocabulary. Finally, you could make a Google site, like a website, and you could explain the plate boundaries. You could show the ring of fire. You could show the mid-ocean ridge, great pictures that you could put on your website. But specifically, I'm looking for our vocabulary information about why those fault lines would happen or how that volcano would erupt through a weak spot. So you do still have to mention the stresses and the plate boundaries. Okay. Now that you've got, hopefully, your notes downloaded, remember to submit your notes so I can check them as well. And I have given you mine as a backup, and you can submit your notes on my Canvas page. And you can start making your choice. You could start working on this afternoon or tonight, whatever is easiest for you. Thank you, everybody, for watching my lesson. I hope I got you excited about plate tectonics and the Earth's dynamic features. Thank you so much, and I look forward to speaking with you. Take care, everybody. Bye-bye.